I know we did at least one of, I think we did two of these the other day, but I'm gonna do one more to kind of get us warmed up. I want to remind you that the identities that you need to know are in your notes. We talked about them, I had them on the board, maybe you wrote them down, I don't know, but they're in your notes. You need to get these things, you get comfortable with these. Also, I want to remind you, oh, I forgot to put my sign up. Tomorrow is Math League, the last one. Even more exciting than that, though, Thursday is Pi Day. And we celebrate because it is the biggest math holiday. Now, that we still have class, we still will learn, we'll still do stuff, but if you bring in something round and edible and shareable, we'll have a little party and learn at the same time, okay? So round and edible and shareable. So if you bring in a pie, that counts as shareable. I'll have knives, we'll cut it up, it'll be great. If you bring in one cookie, no, that's not shareable. Okay? So bring in, make sure you bring in enough to share. And there is a little bit of bonus associated with that. And sometimes we have more than we can handle. Because, you know, like, just think about it. Everybody in this class, just this one class, I have 6 classes. If everybody in this one class brought in stuff to share, I mean, that's a lot of stuff to share. So the leftovers on Friday, I will take down to the fire station. And they are always so appreciative of that. In fact, last year, the guy said, I was like a day late or something coming, and the guy said, oh, we thought maybe you went somewhere else this year. And I said, oh no, here's your pies and whatever else we have. Very appreciative. Okay, so here's what we're going to start with. I want you to find the exact sign of negative 5 pi over 12. Now, who can remember from last time, how did we do this? How did we do this? Josie?
What times the angles were fast like the sum?
Or the difference, yeah, we're going to add and subtract angles to get this. Now, what are the angles that we can use? Pi over 6, pi over 4, pi over 3, right? Now, I like to think of those with 12 as my denominator. You don't have to. But it's 2, 3, and 4 twelfths. So can you see a combination, any combination, that would either add or subtract to negative 5 twelfths? And remember, you're not limited to these. You could use 5 pi over 6. You could use 3 pi over 4. You could use 2 pi over 3. You can use any of your pi over 6s, pi over 3s, pi over 4s. So can anybody see one? There are lots. There are lots. And no one is better than another one. Just find one. Go ahead, Xander.
I was thinking something like 3 pi over 4 subtracted by pi over 3.
Okay, so this would be 9 twelfths. And you want to subtract 4 twelfths?
Wait, maybe I'm thinking of it.
No,
That
you're
would be
thinking,
4,
no,
right?
perfect.
Is that?
It's set backwards.
Yeah, it's got
We need it to be
It's
negative.
got to be negative.
So wouldn't we want to take pi over 3 minus 3 pi over 4? That would be one combination. So we're going to think of this as the sine. What was it? Pi over 3 minus 3 pi over 4? Is everybody okay with that? I'm kind of surprised. Nobody said negative. That would add up right there, right? I thought that's probably maybe. But this is fine. This is beautiful. Now, what does the identity say? It's the sine of a difference. Sine of the first, cosine of the second, minus cosine of the first, sine of the second. Now you can just blankly copy that down, but kids, you gotta be able to do that on your own. Now what do? We figured out our combination, we've written out the identity, now we well, now we evaluate all of these things. Be careful, because as long as you're using these angles, everything's positive, because it's quadrant one. But as soon as you start moving around the circle, which you're allowed to do, but now things, some of them will be negative, right? So you gotta pay attention to it. All right, what's the sine of pi over 3? Root 3 over 2. Remember, when you're doing this, you can always draw your unit circle. Okay, you can always do that. All right, cosine 3 pi over 4. Negative root 2 over 2. It's in quadrant 2. Cosine's negative. Cosine pi over 3. 1/2. Sine 3 pi over 4. Now, remember, these are the same numbers we got before when we did this. They're gonna all have a common denominator of 4, right? So what am I gonna have? Negative root 6 minus root 2. Okay. All right, I need you to look in your notes now, page 5. We're gonna do some of his examples, and then I got another one I wanna look at. And we'll look at some more of the notes stuff. Okay, so here we are. Which of the following is equivalent to the expression 2 sine cosine? Now, I'm leaving that out for a moment because it's not the numbers that you gotta pay attention to first. 2 sine cosine is one of your identities. What is it? It's the identity for what? 2 sine cosine. It's the double angle sine. So it's the formula for the sine of twice the angle. This is the formula. Doesn't matter what's in the parentheses. 2 sine cosine is the sine of twice the angle. Okay, well, what is the angle in his problem? Pi over 14? So we have a formula for the sine of twice 2 pi over 14, which is the sine of pi over 7. So hopefully that's a match in there somewhere. All right, let's look at the next one. We got a function that is 4 cosine 2x. What is the formula for cosine 2x? Now this is a tricky one because it's actually got 3 versions. And we can just try all of them. Which one of them? Cosine 2x. What's one of those formulas? Cosine squared minus sine squared? Okay, is that an option for me? 4 cosine squared minus 4 sine squared is not there. Okay. What's another option for the cosine of 2x? One minus 2 sine squared? 4 minus 8 sine squared as an option. No, we don't. So I guess it's the other one. What's the last one? 2 cosine squared minus 1. Kids, these are all written at the bottom of the back of page 4. And we had them on the board the other day. I hope this one's there because I'm out of formulas now. Is that there? 8 cosine squared minus 4. Yep, there it is. That double angle cosine, because of the fact that sine squared plus cosine squared is 1, that double angle shows up in 3 different portions. All right, see if you can figure out example 4. Forget the numbers for a moment and look at cosine, cosine minus sine, sine. Start with that and see if you can figure out what's going on. Are we all here today? It looks like. Good deal. What identity is this? Cosine, cosine minus sine, sine. It's a cosine of a sum. So this is a formula for the cosine of something plus something. These are the somethings. So the somethings are pi over 8 and pi over 16. So this is a formula for the cosine of 3 pi over 16. Is that there? Yep. Perfect. So the first problem we did, that I made up, that extra problem, you had to know which formula to use. These, you have to recognize the formula. You have to recognize that cosine, cosine minus sine, sine is the cosine of a sum. And then it's easy. You just stick your angles in and you're all done. Okay. All right, let's jump down to example 5. We got a circle. It is not the unit circle. It's got some point on it, 512. Even if he didn't tell us, could you find the radius of that circle? Yes, it's a Pythagorean theorem problem. He tells us it's 13, but you can figure it out. This is point P right here. This is angle theta right here. And your job is to find the value of the sine of 2 theta. Okay, now wait. I see some of you flipping. Good. What are you looking up? What do you need to know? The identity for the sine of 2 theta, which is 2 sine cosine. Then you'll look at the situation that you've been given, and you will figure out, okay, what are the sine and the cosine of theta? Well, what's the sine? And if you say 12, I will smack you. The sine is not 12. The sine is 12 over 13. Y over R. The only time sine is Y exactly is in the unit circle. Okay, so Y over R. So 12/13 is my sine. And 5/13 is my cosine. So my answer is times it all together. Remember, this is 2 over 1. Let's not do any dumb arithmetic. 2 over 1. So what is that? 120 over 169? Okay, who's got a question about that? Because things are about to get wild and crazy. No, yeah, good. Bring it on. Here we go. All right. So here's another extra problem. Squeeze it in somewhere. Get on the sheet of paper. I don't know. The sine of alpha is 3/5. And alpha is between pi over 2 and pi. The cosine of beta is -12/13. And beta is between pi and 3 pi over 2. And your job is to find the cosine of alpha minus beta. All right. So where to begin? What are some things we need to do to kind of get started? What's this? Cosine, cosine, plus sine. All right, so right there, that's step 1, or a step. That's one of the first things you need to do is figure out which identity you're going to use. And you know, because we've already done a couple, that we're going to eventually need to fill in values for this. Remember the first problem we did today? We were filling in √3 over 2, √2 over 2. We need to find the numbers that go here. Well, the numbers that go here are going to come from the given, right? So let's stop a minute and think about, what do we know about angle alpha? It is in quadrant 2. Would everybody agree with that? And its sine is 3/5. Would you agree with that? Can you find this? What would that be? What'd you say? Okay, watch it. -4? -4, quadrant 2, x is negative. How do you get 4? Those of you that are still on the weekend. Pythagorean theorem. All right, so there's alpha. All right, do the same thing with beta. Where's beta? Quadrant 3. And cosine is -12/13. How do I know to put the 12 on the x-axis? Because it's cosine? Cosine's x over r. All right, same deal, find this side. What's this guy gonna be? -5? We're ready. What's the cosine of angle alpha? The cosine of angle alpha? -4/5. What's the cosine of beta? Well, actually, they told us that, but we can get it from the picture. -12 over 13. Sine alpha, 3/5. And sine beta, -5/13. Now we do the math. This one is going to be 48/65. And this one is going to be 15/65. I know you can cancel, but don't, because you want to keep that common denominator so that you can add them. And we can add them, and our answer is 33/65.
I know you're adding version like plus cos A cos B plus or minus some.
Well, but look, we talked about this on Friday, because this is plus or minus. So if you're doing the plus, you use the minus. If you're doing the minus, you use the plus. Right? So I got a minus, so I'm going to do plus first. Okay? All right, page 6. Check your understanding. Here we go. Page 6. Xander, why am I hearing your voice?
You don't explain.
I heard the word spring break in there. I don't think you're explaining anything.
I was just showing.
I may be old, I am not senile yet, okay? All right, here we go. Number 1, check your understanding. Secant theta is 4, and we're supposed to find cosine, tangent, sine, cosecant, and cotangent. Okay, this is not a hard problem, but it might be the first time we've actually discussed it, that if we know one function, in this case secant, we can find everything else. Now, what is ambiguous in this case is, where am I? Because secant, it doesn't say in there, does it? Nope. Secant can be positive in 2 places. Where is it positive? Quadrant 1 and quadrant 4. Secant is reciprocal of cosine, so it's associated with x, positive where x is positive. Now, clearly, if the secant is 4/1, then the cosine will be 1/4. There's no ambiguity there. But do you see what's going to happen with the rest of these? If the angle is in quadrant 1, then they're all going to be positive. But if the angle is in quadrant 4, all of these will be negative, okay? The way they wrote the problem, there's no way to know, so we're going to have to put plus or minuses on these. Normally, it will be written the way my problem was written, where I say alpha is between this and this. So then you know, okay, I'm in quadrant 2 or wherever. Here we don't know. So does everyone understand why these will be plus or minus? Okay, now let's look at the situation. Just for kicks, I'm going to put it in quadrant 1. If the secant is 4/1, can you find the y? Yes, you can. And it will not be a whole number. It will be some radical, square root of 15. You are. If you were thinking root 17, shame on you. Remember, the hypotenuse is c. So it equals 16. All right, so here we go. What's the tangent? Tangent, so this is a positive 1. It could also be down here where this would be negative root 15.
Plus minus 4.
Be careful, what's tangent now? Tangent is y over x. So won't it be plus or minus the square root of 15? Y over x. You're all looking at me. You got it? You see it? Okay. Now, what does that mean cotangent will be? 1 over root 15? What about sine? Root 15 over 4, which makes cosecant 4 over root 15. We good? You're gonna be able to do that always if you know one function. Because if you know one function, you will know two of these numbers, and then you can Pythagorean theorem to find the third one. Okay. All right. Simplify each expression to one number or one trig expression. So, we have secant squared, 1 minus sine squared. Tell me your thought. And maybe look up here in the box where I wrote down some stuff for you. I'm hopeful that like comes out at you, like it's in bold highlighter or something. What is 1 minus sine squared? Cosine squared. This is cosine squared. One more time, I know we talked about this last time, but I'm gonna talk about it one more time. The fundamental trigonometric identity says sine squared plus cosine squared is 1. That is an equation and you can rearrange things in it. So if you were to take this and subtract it over to the other side, what would it say? Cosine squared equals 1 minus sine squared. Well, what happens when you multiply a secant squared times a cosine squared? They cancel because aren't they reciprocals? Your job is to simplify that to a single number or a single expression, and there you go, it's 1. Anytime you multiply a secant and a cosine, they're going to cancel. Anytime you multiply a sine and a cosecant, they're going to cancel. Tans and cotans are going to cancel when you multiply them. Now you add them, but when you multiply them. All right, you try this one. Cosine squared plus sine squared, ding, 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 over secant. Come on, what's the numerator? 1. What is 1 over secant? What is the reciprocal of the secant? That's it, cosine. You're done. That one just goes to cosine. All right, I'll shut up. You laugh at number 4. See if you can figure out what secant squared minus tangent squared would be. Who's got an idea? Julia? Julia says it's 1. I'll put that over here. I don't know. What do the rest of you think? Agree? You have an identity that says 1 plus tan squared is secant squared. So if we move this, if we bring this over here to this side, which you're allowed to do, it's going to say 1 equals secant squared minus tangent squared. Perfect. 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 Remember that these things are written like that, but you can rearrange them. You can think about them in lots of different ways. All right, this is an equation that you are asked to solve. So I want you to look at it. We'll solve it between 0 and 2 pi, like always. They included 2 pi. All right. careful. This right here is 1, you're saying? So I am going to subtract that. This is an equation I'm solving. So I'm going to subtract that. So cosine W will actually equal -1/2. Maybe that's what you said, I'm sorry.
Yeah.
Are we okay with that? Perfect. Where does the cosine equal 1/2? What kind of angle? Pi over 3, pi over 6, pi over 4. Cosine 1/2 is pi over 3. Since it's negative though, it would be over here or here. So what are the pi over 3's? 2 pi over 3 and 4 pi over 3. Nice work. Okay. All of these except one, I guess, is not a cotangent. Okay. Well, I'm not even gonna write down B. Don't I know B is cotangent? B is cotangent. That's the definition. Cosine over sine x over y. So I'm not gonna worry about that one. All right, but I got the rest of these. I'm gonna check them all. I'm not sure how many don't match or how many aren't cotangent. I know B is, so B is definitely a match. What do you think about this? We have an identity that says 1 plus cotangent squared is cosecant squared. Don't we? Isn't that one of our Pythagorean identities? So if we subtract 1, cotangent squared is cosecant squared minus 1. So what would cotangent be? Wouldn't this be cotangent, the square root of cosecant squared minus 1? Technically this is plus or minus, but that does equal cotangent. So that one's good. That one's okay. What about this? What's secant? Secant is 1 over cosine. And then I'm over 1 over sine. Now that would be times sine over 1. Am I losing anybody if I multiply by the reciprocal? So that's going to end up being sine over cosine, which is not cotangent. So that one is not. That actually equals tangent. All right, let's see what this is all about. 1 over sine times 1 over cosine minus sine over cosine. What do you want to do with that? Could we get a common denominator? This is 1 over sine cosine minus, could we get a common denominator there? Yeah? We have to multiply this one by sine. So now we have a common denominator. And I can write it as 1 fraction. My numerator would be, oh, what's my numerator? 1 minus sine squared, and what is that? Cosine squared over sine cosine. Uh-oh, folks. Cancel a cosine, and what am I gonna be left with? Cosine over sine, which is cotangent. Trigonometry is so easy, but there's so much to remember. So much to remember. Okay, so I guess they all, wait. Yeah, they all work with that one, I guess, yeah. All right, turn the page to the back of page 7, and we're gonna do it again. We're gonna check our understanding on the back of page 7. Now, they're in degrees. They're in degrees. You have no degrees work at all in this course. Not supposed to have any degrees at all. So I'm gonna tell you that 75 is 5 pi over 12. So we're gonna find the sine of 5 pi over 12. Back in geometry, you did the sine of 30 and 45. That's what 75 is, 30 plus 45, but we have to do it radians. So can you think of two of your angles? I should just leave this up here. What did you say, Oscar? Did you say something? Pi over 6 and pi over 4? That would be this one and this one, that would add up to, no, that'll work, right? So he says I'm gonna do the sine of pi over 6 plus pi over 4. You could do other things. Remember, you can use 2 pi over 3 and 5 pi over 4, whatever you want. But that would be the easiest thing. Okay, without looking, who can tell me what's the identity look like? What is it? Go ahead, Raina.
Sine of pi over 6, cosine pi over 4, plus cosine pi over 6, sine pi over 4. Or the other way.
Actually, the order of these two doesn't matter. As long as you've got one group is sine this, cosine that, and the other one is the opposite, these two can be switched. That's not a problem at all. She's exactly right here. Sine of the first, cosine of the second, plus cosine of the first, sine of the second. Beautiful, beautiful, beautiful. So now we're going to start plugging in numbers and get our final answer. So go ahead, plug them in. Did you get root 2 plus root 6 over 4? Beautiful. Next one, on your own, you're finding the cosine of 250, or the cosine of 17 pi over 12. Find the cosine of 17 pi over 12. Now be careful, you will have to go outside of quadrant 1. So you will have some negatives to contend with. Let's see if you can find, first of all, two things that add up or subtract. You can add or subtract to 17 over 12. have a final answer yet. I'm gonna do it here in a minute, and I just wanna see if we're on the right track. Here's what I got, I don't know. No, Raina, do not erase yours, I don't know if this is right or not. You could be totally right. What's different for us?
I'll use pi over 2 and 3 pi.
Wait, pi over two,
Oh, that equals 15.
I don't think that combination will work. I'll tell you, Raina and everybody else, I don't recall ever doing one of these problems and using a quadrantal. So pi over 2, pi, 3 pi over 2, I wouldn't use those. I think you always need one of your 6s, one of your 4s, or one of your 3s. Lots of possibilities. I did 7 pi over 6, which is 14 twelfths, and pi over 4, which is 3 twelfths. That's the combination that I used. But no matter what we used, we should have the same thing. Now, it might be turned around. It might be root 2 minus root 6. That's fine. Did anybody else get this? What did you use, Xander?
I use 3 pi over 4, 2 pi over
3
3.
pi over 4 and 2 pi over 3. That would make 17, yep. Any question about that? Okay, now we've already talked about number 3, so I want to skip it and go down to number 4. I want you to solve this equation, and you can do it with your partner. You and your partner can work on this equation together. We're gonna open that after class, we're not gonna open it now, we're doing math right now. I'm just trying to save everybody some time here.
Okay, that's what I'm thinking.
Yes. I just, you did my class, teacher, what you got?
That's not quite
ahead. No. No, I'm glad you did that. This expression right here is unbreakable. In other words, you can't factor things out of it. What you can do with it is replace it with what it equals. What does sine 2x equal? 2 sine cosine. Guys, listen to me. This is kind of a big deal. This and this are two different variables. Okay? We don't solve equations that have two variables in them. We don't do that. So the first thing you want to do is make your variables match. Okay? Josie?
I've done it as like the sine of x plus x and then just simplify it down.
Absolutely. And but when you do that, Josie, this is what you're going to get. So this just saves us all that work. But yes, that will happen. Okay? Now, at this point, what do I do? Some of you mess this up on your quiz. You had a problem that looked almost exactly like this on the quiz. Some of you messed it up. What do I do at this point? Factor out a sign. I factor out a sign. I do not add sign over and divide. No, 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 no. I don't know how else to say it. No. You don't divide by variables. Sine x is a variable. So what we do is factor it out. So what will that leave me with? 2 cosine minus 1. Then as with all factoring problems, I set them equal to 0. And figure it out. Okay, where does sine equal 0? Guys, your brain, you guys have big brains, you're very smart, but there's only so much crap you can have on the tip of your tongue all the time. Think of your circle. Sine is 0 here and here, right? So what are those angles? 0 and pi. Now on the quiz, you had to stop there, but because of these instructions, we're going to actually also include 2 pi. And then where does the cosine equal 1/2? I don't know, somewhere over here. What angle has a cosine of 1/2? Pi over 3, and then of course, 5 pi over 3. And there are the answers to the question. Got it? Okay. So I now consider your 312 homework assigned if I haven't assigned it already. And I want to look at problem number 1. We actually have talked about, I think, everything on here. We should be good to go on this homework. But I want to talk about number 1. We did 1 the other day. But I want to back up and make sure, pretty easy problem. I just want to make sure everybody's with the program. This is from the 312 homework, problem number 1. It says the whole thing has to be sine. So right now, it's cotangent and secant. Okay, what might be the first step?
You might want to get it into more basic terms like cosine over sine.
I love it, basic terms, break it down into the very basics, which are sine and cosine. So he says this is cosine over sine. And what is secant? 1 over cosine. Now we had this a minute ago. I have a fraction divided by a fraction. It's okay, I'm just going to invert and multiply. So this is going to be times cosine over 1. So now I've got cosine squared over sine. Is everybody with me? And I'm all good, except I have to write this. The only function I'm allowed to have in my answer is sines. Okay? This is really good news. Cosine squared is really good news, because what is cosine squared? 1 minus sine. Nothing cancels, so don't get crazy and start doing dumb arithmetic stuff. The answer is right there. You have rewritten the problem in terms of sine only, and that was your job. Okay? I'll leave the rest to you. I'll stop there. You get gathered up, grab your phones, go back to your seats.